Imagine a machine that could run forever without ever needing more fuel or energy. It would power itself endlessly, defying the need for batteries, plugs, or even the sun. For centuries, inventors have dreamed of building such a device, a perpetual motion machine. But no matter how creative or determined these inventors have been, their dreams have always run into the same stubborn wall: the laws of physics. To understand why perpetual motion machines don't work, let's start by defining what they are. A perpetual motion machine is a device that, once set in motion, keeps moving forever without any additional energy input. Some designs even claim to produce more energy than they consume, promising to power other devices or even entire cities for free. At first glance, it sounds like a brilliant shortcut to unlimited energy. But there's a catch. Perpetual motion machines would break some of the most fundamental rules that govern our universe. The first of these rules is the law of conservation of energy, also known as the first law of thermodynamics. This law states that energy cannot be created or destroyed. It can only change from one form to another. If you wind up a clock, for example, you're storing energy in the spring. As the clock ticks, that energy is gradually released, turning gears and moving hands. But once the energy runs out, the clock stops. You have to wind it again to keep it going. There's no way to get more energy out of the clock than you put in. Perpetual motion machines, by contrast, claim to produce energy from nothing. But according to the conservation of energy, this is impossible. No matter how cleverly a machine is designed, it can't output more energy than it receives. If it tries, it will soon slow down and stop, just like a clock that's run out of winding. But even if a machine isn't trying to create energy from nothing, even if it just wants to keep moving forever, it still faces another obstacle: friction. Friction is the force that resists motion whenever two surfaces rub against each other. It's why a spinning top eventually comes to a halt, why a rolling ball slows down, and why even the most carefully balanced wheel will eventually stop turning. Friction converts some of the machine's kinetic energy into heat, gradually draining away its motion. Some inventors have tried to minimize friction by using smooth surfaces, ball bearings, or even magnets. But no matter how much they reduce friction, they can never eliminate it entirely. And even if they could, there's still another force to contend with: air resistance. As any object moves through the air, it pushes against the molecules in its path, losing energy in the process. In the real world, there's always some resistance, some loss, some drain on the system. Let's look at a few famous examples of perpetual motion machines. One classic design features a wheel with weights attached to its spokes. As the wheel turns, the weights are supposed to shift outward on one side and inward on the other, creating a constant imbalance that keeps the wheel spinning. But in practice, the energy needed to lift the weights back up cancels out any advantage gained from their downward motion. The wheel slows and stops, just like any other. Another popular idea is the overbalanced wheel. This design uses containers of liquid or rolling balls that are supposed to move in such a way as to keep the wheel unbalanced and spinning. But once again, the energy required to move the balls or liquid back to the top of the wheel is equal to the energy gained from their descent. Nothing is gained, and the device eventually comes to rest. Even more sophisticated attempts, like using magnets to create a machine that pushes itself along, run into similar problems. Magnets can attract or repel, but they don't provide a free source of energy. Any motion they create comes at the expense of the energy stored in the magnetic fields or in the movement of the machine itself. But what about machines that seem to run forever, like the swinging pendulum of a grandfather clock or the spinning Earth itself? The truth is, even these systems are losing energy, albeit very slowly. The clock's pendulum will stop unless it's rewound, and the Earth's rotation is gradually slowing due to tidal forces. Nothing in the universe is truly free from friction or resistance. So, are perpetual motion machines truly impossible? According to our current understanding of physics, yes. The laws of thermodynamics are among the most thoroughly tested and reliable principles in science. They tell us that energy can't be created from nothing, and that every real-world process involves some loss. usually in the form of heat, that doesn't mean the quest for efficient machines is pointless. On the contrary, striving to reduce friction, improve efficiency, and harness energy more effectively has led to countless technological advances. But the dream of a machine that runs forever without input remains just that, a dream. The next time you hear about a new invention that promises endless energy, remember the lessons of physics. Perpetual motion machines are fascinating to imagine, but they're destined to remain in the realm of fantasy. Instead, our best bet is to keep searching for smarter, more sustainable ways to use the energy we have, always mindful of the laws that govern our universe. And in that pursuit, the real magic isn't in breaking the rules, it's in understanding and working within them.